A huge challenge. The sources lay out a very clear data spectrum that really dictates how the search and the extraction has to operate.
And there are three major types.
Three major types, and they're important because they determine the processing cost and, frankly, the feasibility of structuring all this information.
Let's start with the most common, and I assume the messiest type, unstructured data.
That's your plain text. Billions and billions of web pages, news articles, social media posts, you name it. Search here has to rely on traditional full text search because there is no defined structure. There's no schema.
So it's cheap to get, but it's hard to process.
Exactly. It requires the most complex downstream processing like entity linking, which we'll get to later, to actually impose some structure on it.
Okay, then at the complete opposite end of the spectrum, we have structured data.
This is your highly organized tabular data. Think of relational databases. It adheres to a fixed, rigid schema. This data is pristine, it's high quality, but it's closed off. It's siloed away from normal web search.
Because you need special languages to query it.
Right, you need formal query languages like SQL.
And then there's the sweet spot, the one that makes entity-oriented search scalable across the entire public web, semi-structured data.
This is the crucial middle ground. It lacks the rigid schema of a traditional database, but it uses self-describing structures, tags, or markup that make it machine understandable.
So things like XML or JSON.
Or, most relevantly, for KBs, Wikipedia infoboxes, and the RDF model itself. This structure simplifies data processing immensely because all the information related to a single entity can often be contained in one entry.
It's flexible, but it's consistent enough to work with.
It allows for the flexibility of the web. The schema can change easily, while still providing enough internal consistency to make building the graph possible at scale.